Everyone, for today's lesson, we are going to continue our discussion on SOHCAHTOA by looking at applications with trigonometric ratios. Our goal for today is for you to be able to say, I can find missing side lengths of a right triangle using sine, cosine, and tangent ratios. Now, as a review, we learned about SOHCAHTOA. And if you know how to spell SOHCAHTOA, you will know all of the ratios. So one thing that I want you guys to know about SOHCAHTOA is that it represents an acronym where it describes the ratio of each trigonometric function. So for example, sine of an acute angle of a right triangle is equal to the opposite divided by the hypotenuse. Cosine is equal to the adjacent length divided by the hypotenuse. And finally, t represents tangent of an acute angle of a right triangle equals opposite divided by the adjacent. So we're going to be working with SOHCAHTOA to help us to find all of the missing side lengths of right triangles. In example number 1, we want to find the value of each variable and round to the nearest tenth. So looking at the letter X and 44 degrees, which is the angle that's given to us. For all of these problems, we always use given information if we have a choice. So I'm going to actually write that down. Always use given information instead of acquired information. Acquired information, meaning like information that you received from a previous step, just in case you make an error along the way. So we always use given information instead of acquired information unless we have no choice. So what is given to us is 44 degrees. Could we work with this angle over here, which is 46 degrees? Of course we can. But always work with given information. And with respect to 44 degrees, X is across from it. That makes it the opposite. 14 and Y, identifying which one's the hypotenuse and adjacent can be very tricky for students. But in this problem, 14 is opposite of the right angle. So that makes it the hypotenuse, leaving Y as the adjacent. So we want to find X and Y. And so this is a two-step problem. Step number 1 is we need to find X. With respect to 44 degrees, X is the opposite. We are given the hypotenuse. So when we're trying to find X, we need to make the decision of should we work with sine, cosine, or tangent. Since we want to find the opposite and we know the hypotenuse, that's an O and an H. We should work with sine. So we're going to write the sine of 44 is equal to the opposite, which is X, divided by the hypotenuse, which is 14. Now remember that sine of 44 is just a number, and we can make that number over 1 and use cross product. So I'm going to multiply 14 times the sine of 44, and that's going to give me X. And as long as you have a calculator with a sine, cosine, and tangent button on it, then you should be perfectly fine with coming up with these answers. So I'm going to go 14 times the sine of 44. And when I do that, I end up with 9.7. So since I know that this is 9.7, I could use it to find Y. I could work with 44 degrees, opposite, adjacent. I could work with tangent. Because this is a right triangle, I could also use the Pythagorean theorem to find Y. 9.7 squared plus Y squared equals 14 squared. But like I said at the very beginning, we want to make sure that we get our answers correct. So what if we made a mistake in step 1? If we use 9.7 to find Y, and 9.7 was a mistake, then we're using an error to find our next number, and that will also be an error as well. So once again, I'm going to reiterate that we always use given information instead of acquired information. So for step 2, being to find Y, I'm going to go back to what was given to me. What was given to me was 44 degrees and the hypotenuse. So we want to find the adjacent given the hypotenuse. That's an A and an H. So we're going to be working with cosine. So I'm going to write that the cosine of 44 is equal to the adjacent, which in this case is y, divided by the hypotenuse, which is 14. Cosine of 44 is just a number, and we can put that number over 1 and use cross product to find y. So this is 14 times the cosine of 44 is equal to y. And now I'm going to put this into my calculator. 14 times the cosine of 44. And when I put that into my calculator and round to the nearest tenth, I end up with 10.1. And there is our answer. All right, let's go ahead and look at A, B, and C. A, B, and C are pretty much the exact same things as what we had before. Those of you who are struggling to read the numbers, this number right here is 36 degrees. This number is 11. This is X and obviously Y. Down here, this is 18, which is the opposite. And over here, the degrees are 57 degrees. So I know that the printing kind of turned out kind of weird for this problem. Okay, so if you are interested, you are welcome to pause the video and go ahead and try example 2 on your own, or you can hang out with me and we can go ahead and do these problems together. So looking at letter A, it's the same exact directions as before. We want to find the value of the missing sides and we want to round our answer to the nearest tenth. Always keeping in mind SOHCAHTOA, and I strongly recommend that you always label given information with respect to the angle that's given to you. So with respect to 36 degrees, X is across from it, making it the opposite. Y and 11, we have to make a decision, which one's the adjacent and which one's the hypotenuse. Since 11 is across from the right angle, that's going to make it the hypotenuse and Y is the adjacent. So I want to find what the opposite is. I am given the hypotenuse. So OH, I'm going to be working with sine. So the sine of 36, so this is number 1, we're going to find X. The sine of 36 is equal to the opposite, which is X, divided by our hypotenuse, which is 11. This is over 1 because sine of 36 is a number, and I'm going to use cross product. When I do that, I end up with 11 times the sine of 36 is equal to X, and I'm going to put it directly into my calculator. So I'm going to write 11 times the sine of 36, and when I do that, I end up with 6.5. So as you guys can see there, that 6 makes this 4 go up. So 6.5 is equal to X. And at the very bottom, I have like a little box, and we're going to put X is equal to 6.5. For number 2, we need to find Y. And I know the hypotenuse, and Y is the adjacent. So AH, I'm going to be working with cosine. So I'm going to write the cosine of 36 is equal to the adjacent, which is Y, divided by the hypotenuse, which is 11. I'm going to put cosine of 36 over 1 and use cross product. So now I'm going to write 11 times the cosine of 36 is equal to Y, and I'm simply going to put this into my calculator. 11 times the cosine of 36 is equal to 8.9 if I'm rounding to the nearest tenth. And those are our answers. Let's go ahead and look at letter B. For letter B, I am given 65 degrees. And with respect to 65 degrees, I know that 18 is across from it, making it the opposite. Making the decision between the hypotenuse and the adjacent, I know that Y is across from the right angle, making it the hypotenuse. And X this time is the adjacent. So step number 1, we need to find X. And with respect to 65, X is the adjacent. And based on given information, I know the opposite. This is A and O, or O and A, and that's going to come from our TOA, which is tangent. So I'm going to write the tangent of 65 is equal to opposite, which is 18, divided by the adjacent, which is X. And one really cool trick, if you were to make this over 1, do cross product, and divide both sides by tangent of 65, after you show all of that work, ultimately, a shortcut is that you simply switch x and the tangent of 65 in their positions. So this is going to be x equals 18 divided by the tangent of 65. And we're simply going to put that into our calculator. 18 divided by the tangent of 65 degrees. And when you do that, you end up with 8.4. So down here in the box, I'm going to put 8.4. And now I'm going to go on to step 2, which is to find y. To find y, if you look at our picture, y is the hypotenuse. And could we work with the 8.4 in our last step? Of course we can. But what if we made a mistake? And if you're using a mistake or you're using a really rounded answer, you might end up with an incorrect answer in your next step. So we really don't want to do that. So we're just going to work with given information. So I know the opposite. I want to find the hypotenuse. That's O and H. And that means I'm going to be working with sine. So the sine of 65, that's equal to the opposite, which is 18, divided by the hypotenuse, which is y. And once again, because our variable is in the denominator, we can flip-flop the sine of 65 and y. That's considered a shortcut. So I end up with y is equal to 18 divided by the sine of 65. And now I'm going to put this into my calculator. 18 divided by the sine of 65 degrees. When you put that into your calculator, you end up with 19.9. And that is your answer. We have one more problem, and then the remaining problems are problems that I would like you guys to complete on your own, and we will discuss those the next time that I see you. So let's go ahead and look at letter C. For letter C, with respect to 57 degrees, I know that y is the opposite, x is the hypotenuse, and 14 is the adjacent. So if I want to find x first, I am given the adjacent, and I want to find the hypotenuse. AH, that means I'm working with cosine. So the cosine of 57 is equal to the adjacent, which is 14, divided by the hypotenuse, which is x. Because x is in the denominator, I can flip-flop the cosine of 57 and x, so that I end up with x is equal to 14 divided by the cosine of 57. When you put this into your calculator, it's 14 divided by the cosine of 57 degrees. You're going to end up with 25.7. And I'm going to put 25.7 directly into my box down here. Step 2, we want to find what y is. So using given information, I know the adjacent. Y is the opposite. That's OA. I'm working with tangent. So to find y, I'm going to work with the tangent of 57 is equal to the opposite divided by the adjacent. So y divided by 14. So this one, I have to just do cross product. There does exist a trick. You're simply going to multiply these together and it'll equal y. That's another way to view it. So I'm going to write y is equal to 14 times the tangent of 57. And when you put this into your calculator, 14 times the tangent of 57, this ends up equaling 21.6. And that is the end of today's lesson. If you have any questions over anything when it comes to finding missing side lengths of a right triangle, please feel free to email me. Otherwise, I hope you have a wonderful day.